Unlocking power of structured data with Amazon Bedrock knowledge bases. My name is Ron Wida. I'm a senior software development manager for AWS, based out of New York. And right next to me, I have Saket Sorab, a principal software engineer for AWS too. Our team supports the Bedrock knowledge bases team. So really thank everyone for coming in the morning, Friday, after replay. Really appreciate it. Show of hands, how many people here are already familiar with Retrieval Augmented Generation, or RAG? Okay. And how many people have heard of Bedrock knowledge bases? Use knowledge bases already? Oh, perfect. Awesome. So I think we've got agenda for pretty much everyone. We're going to first start establishing some context for those of you who are slightly newer to the topic. What is RAG? Why is it important? We will then contrast the difference between approaches for unstructured data that many of you hopefully already been using or been building, as well as how to approach structured data. Then we will spend the most time diving in deep, focusing on the structured data side. So let's get started. So think about what was the last prompt that you're asking to an LLM. For me, at least, it's kind of like something like this. Can you improve this paragraph? Can you summarize this article? Can you solve this math problem? Can you explain this complex topic? And foundational model excels at understanding and generating natural language. It has all the general knowledge because it's pre-trained with a lot of this data and knowledge from books, from website, papers, and articles and code repositories. However, let's wear a different hat. If I ask you if you're a CEO or a CTO of this fictional company called Any Company Marketplace, and it's a new retail marketplace that is chatbot or AI first. Now your job, our job together, is to envision this new user experience. Let's ask that question again. What prompts do you want any company to be able to respond to? I think the answer probably is very task-focused, right? So for example, one, I think right away customer support. So what is your return policy? And since our company is a fictional one, it's just recently established too, none of the models have context over what specifically our return policy is. It knows about the typical return policy, and perhaps if we just rely on it, it might hallucinate and pull in a different return policy that's not ours. That would be a disaster. So we will have to somehow customize or extend the knowledge that the foundational model have. And how do we do that? Again, probably some of you already know this, right? This is by no means an extensive kind of list. One side, you can train foundational model from scratch. It's the most complex. It's the most time-consuming, resource-intensive. You first have to determine the model architecture, and then you have to collect and gather all the data. And this data is like from scratch. It needs, the model needs to know about language, culture, tone of voice, some of the role that we want to assign to it, and then bring in our own data, spend a lot of compute and expertise to train this, benchmark, and rinse and repeat until you have a model that you're happy with. In many cases, this is just not feasible for a business, right? For any company, we're focusing on retail. We don't want to be in the business of building models. The next one is, and this is something that you can do easily with Bedrock, well, just use the off-the-shelf foundational model, bring your own data, and then customize it. And there are two ways in Bedrock that you can do that. You can do fine-tuning, or you can do continued pre-training. With fine-tuning, you can take labeled data set. With continued pre-training, you can use unlabeled data set because it's an unsupervised learning approach, and then you'll get the outcome. And it's great for fairly static data, slowly moving data, and this is one of the approach. On the other side, this is probably something that we all use on a day-to-day basis, right? We've got prompt engineering or prompt tuning. We simply can start with prompt priming, for example. You start with saying, you are a customer agent Q&A chatbot, and your responsibility is to answer these kind of questions, and you cannot talk about these kind of questions, and you'll start with that. The challenge with prompt engineering is there's a limit to the knowledge. You're really inherently leveraging the knowledge that's already there in the foundational model that's already being pre-trained on. And just like what we talked about before, our return policy, it doesn't know anything specific about that. So then, I guess we come into, ideally, wouldn't it be better if I can just pre-select, curate the nuggets of information external to the foundational model, but specific to my business, and then pass it on every single user prompt into the foundational model so that they know exactly, so that it knows exactly what possible responses that it can answer. Our answer can be grounded by the information, the knowledge that's available in our repository. And that is where retrieval, augmented generation, or short for RAG, kind of comes in. So what is RAG? As the name suggests, we start with retrieval. User prompt comes in. We fetch the relevant information. These are all the possible answers that the foundational model can choose from. And it's great because it's giving us, the developer or the business, a lot of control and flexibility in how you want the foundational model to respond to the customer instead of relying on just the model itself. So it reduces hallucination. It increases accuracy. It is focused on a particular job. And then like what I said before, once we retrieve all those relevant content, we augment it to the user prompt, and we pass it to the foundational model to finally generate the final response. Now, let's talk about the type of retrieval. Right, Ron, sure. Like you're just skimming the surface on fetching or retrieving the relevant information. How do you do that? Well, the first one is search, right? Makes sense, keyword search. If the user prompt is asking certain kind of like keywords, maybe you have some ways to kind of determine what keyword is more important. You pass it to your enterprise search. You pull in the relevant result. That's a reasonable point to start with. However, what happens when you don't have an exact keyword matches? What you want instead is really searching based on semantic, the meaning of the word. So one approach of doing this is, and this is something that hopefully many of you are already super familiar with, put all the keywords, put all your documents and phrases within the documents, turn that into a set of vectors using a foundational model, let's say, put that in a multi-dimensional vector space, and then when you have a user prompt comes in, you can do a vector similarity search based on, if the user prompt is this, pull up some of the relevant document or relevant information that might be helpful for me to respond to such question. So what do I mean by that? Super easy. If I put in the word New York, right, and represent that as a vector in this multi-dimensional vector space, when I do a vector similarity search, I probably would get results like subway, Statue of Liberty, tall buildings, even though they are not exact matches. And I'm always impressed, like the vector representation of the word coffee, and you do arithmetic operation with the vector representation of the word milk, is equals to a vector representation that's closely related to the word latte, for example. It knows a lot of kind of meaning behind those words. So Bedrock knowledge bases really helps customers to build such a RAG workflow. And the way it works for unstructured data, and this is something that was launched last year at reInvent, this is not anything new. User query comes in, what's your return policy for this item? You call Bedrock, and Bedrock uses Bedrock knowledge bases underneath. It's going to say that the relevant information is the following document, return policy is, etc. And then we augment the prompt. You are a customer agent. Given the context of the information and not prior knowledge, answer the following query. This is the query, and these are the following relevant documents. And then finally, the generation stage. We pass it all to the foundational model, and you get a nice conversational response back. Hi, rest assured that if for some reason the item isn't to your satisfaction, you can always return the item. So this is hopefully nothing new, right? The unstructured data. So let's get to the exciting bit. Back to our any company chatbot experience again, this might not be the only question that your customers would want to ask. I'm anticipating some structured question too. Things like, do you have size 9 available? What is my order status? Or maybe more interestingly, internal employee question. What was the top selling product in November 2024? Or who was the prestige partner in November 2024? And let's say prestige partner in this case is a term that we use for our seller, our channel partners, where they're producing the most revenue for that month. This is very specific to our business. The foundational model knows nothing about it. And we need to kind of figure out a way how we can also answer some of these questions. So let's dive in deeper to one of the questions, right? What was the top selling product in November 2024? Do we think the previous approach, the semantic search, can help us here? Sure, maybe. If there's like a document, right? Someone already produced that report, we can kind of pull it in, maybe. But that requires an analyst to produce that document on a regular basis. But traditionally, businesses, just like any company, store this type of information in a structured format, in a database engine, or maybe even in a Parquet file sitting in your data lake. And it's going to look something like this, right? There's a table eventually where you have all your orders, whether you have your total amount. But the question is, what was the top selling product? We don't even see the product information here. OK, so there's another table, product ID, and joined with the order. I get it. But I don't want to get product ID back. I want to get the actual product title. So I have another table. I have to do another lookup. And of course, with any databases, it's usually big. You have a lot of tables. And for this particular query, you only care about specific kind of parts of it. The reality here is that the answer doesn't live in a document. The answer doesn't live in a single table. The answer doesn't live in a single row. And in order for me to be able to answer this question, it requires lookups, aggregation, filtering, because I only care about November. And potentially, if I convert that query from what was the top selling to show me all the top selling products, I may also even care about the ordering of such a response. And ultimately, to answer this question, what we think is accessing structured data requires much more than semantic search. That multidimensional vector search space is useful in so many different ways, but because of the richness of the query that we just talked about before, we need a whole different approach. And what is the approach? We think that the best approach is really to translate the natural language user query into a language that these databases engine understand, right? And that's the structured query language. And it brings us back to these types of retrieval, and we think that there should be a third type of retrieval that knowledge base, Bedrock knowledge base should be supporting, and that is structured data. So we think that natural language to SQL is the RAG for structured data, and this is how it works on Bedrock knowledge bases. On Wednesday, we're super excited to announce the structured data retrieval in knowledge bases. What you see before when a user query comes in, and in this case, what was the top selling product in November, we send that to Bedrock knowledge bases. The Bedrock knowledge base will generate the SQL query for you. In this case, that particular SQL statement there. It executes the SQL query into the database, in this case, Redshift. We get the tabular responses back. And then finally, we pass it on to the foundational model that you pick to generate the final answer based on the tabular response that we get back, which is in this case, in November, the top selling product is so-and-so. Now, Ron, you told me before, foundational model is pre-trained with code repositories, and probably some of you are relying on a foundational model on a day-to-day basis to help you with your coding, reviewing your design doc, and all that. I'm the same. Why do we need Bedrock knowledge bases? Can't we just use foundational model and be done with it? What's so hard about this problem? So I'm going to pass it on to Saket to talk a little bit about how we're solving the natural language to SQL problem inside Bedrock knowledge bases.
Okay, thanks, Ron. So let's try to understand why text-to-SQL is hard. LLMs have solved the problem of understanding human language very well, but still there are certain challenges which are unique to text-to-SQL. And we'll look at some examples to understand why. So for example, let's take this query. I've taken this query from one of the standard text-to-SQL benchmarking data set. This one is called BIRD. Now this question is asking to count the number of schools in Alameda County that has less than 100 test takers. If we take this query and prompt any of the LLMs to ask and generate a SQL query that can answer this question, we'll probably get something like this. Seems like a reasonable query that serves the purpose that we're trying to do here. But when you try to execute this query on the database that comes with this data set, the query execution is going to fail. And the reason for that is because when we prompted LLM did not have the context of the schema of the table names, the column names. And you can see the difference in both of the queries here. So what this tells us? This tells us that the text-to-SQL generation process needs to be personalized for your database schema. It needs to understand your table names, your table structure, your column names, how those columns are connected in order to generate a useful query. Let's take another example. This is again from the same data set. This time, when I prompted the LLM, I actually provided the associated metadata schema. And we actually got pretty amazing query. If you execute this, this will execute. But the problem is it will return 0 results. And the reason is, when you look at the database, the country in this database is not stored as country name, but rather country code. What this tells us is not only personalization to your schema is required, personalization to your data and how it is formatted in your data store is also required. So you might be wondering, does that mean the text-to-SQL engine needs to go read and process all the data that is stored in my database to be able to understand how this data is formatted? Not necessary. Turns out what we can do is we can just look at the past queries that have been executing on the database, and that can give us pretty good insight into how other users of the database have been accessing some of these fields. So for example, in this case, if we looked at the past query executed on this database, we would have known that every time somebody was running a query with the country field, they were always referencing country code and not country name. Okay, so let's take another example. Now, this time, this query does exactly what it is supposed to do. But when you try to execute it, you get this error. Now, this is the error is saying that contestant number is an ambiguous field in the database, in this query. To solve this query, for SQL experts, you might already be aware. All you need to do is, whenever you are adding a column name, you must always prefix it with a table name so that the query engine understands which column name are we talking about. But what that tells us is that text-to-SQL process also needs to understand these fine details of the SQL dialect and how to frame those queries correctly. And that is what I mean by saying that personalization to your query engine is required. So looking at all of these three examples, what we established is that using an LLM out of the box is not going to help us give good accuracy over text-to-SQL. And this is exactly what we in knowledge bases team have been trying to solve. So let's see what we are trying to do. Firstly, knowledge base taps into the database metadata of your databases. It fetches your database schema, It looks at all the past queries that have executed in your databases. It leverages its deeper understanding of the SQL dialect of the query engine that you are using. And as a result, it is able to generate each query that is customized to your specific data setup. Let's say you are still not happy with what Bedrock knowledge base is generating. In that case, the platform is going to offer you certain query configuration that can help you further customize the SQL generation process. You can do things like adding custom vocabulary, adding how to add advanced complex queries by giving some examples. We'll get into the details of some of these things during the demo section of our presentation. Lastly, Bedrock knowledge base inherently is conversational in nature. What that means is that it has an inbuilt support of session management that makes the interaction to your database much more natural. And all of this combined helps us offer a fully managed structured data retrieval, which is personalized, context-aware, and secure. Now, what do we mean by when we say secure? Two things. One, Bedrock will never read or move any of your data from your SQL databases. And second, any data that is being processed by Bedrock knowledge bases to generate the SQL or to execute the SQL is not going to be stored or used for service improvement. OK, so we are at the demo part of our session. We're going to go through some recorded demos. So let's start with this. I'm going to use AWS console for this demo, but whatever I'm going to show you, you can do everything, even using our SDK. So you can find knowledge bases under the Builder Tools section of our console. To get started, we need to first click on Create. So as of this week, there are 3 types of knowledge bases that can be created. Knowledge bases for vector store and GenAI index. They are catered towards unstructured data, while what we are interested in today's demo is knowledge bases with structured data. So first set of configuration, you need to pick a name of your resource, add some description. You can always come back and edit it anytime in future. These are just for housekeeping purposes. So I picked the name reinvent demo. I moved on. OK, so next is this query engine configuration. As you see, today, Redshift is the only choice here. We definitely don't want to stop here. We want to expand and support other query engines. If you have anything specific that you're interested in, do come and talk to us after. Now, let's next is we have IAM permissions. So any Bedrock, whenever you create a Bedrock knowledge base, you must provide an IAM role. This IAM role is what is used by Bedrock to interact with your data, which means that accessing your, executing query on your data, and this IAM role should have appropriate permission to execute the queries as well as read the data. You can choose to create here the IAM role yourself and pass it to us, or let console do the magic for you. Lastly, there are some tags configuration like any other AWS resource. We're going to skip that for our demo. This is another page of bunch of choices that we need to go through. So this page focuses on where your data is sitting and how your data should be queried. So first configuration is about the choice of query engine. So Redshift, because we are only offering Redshift as a query engine right now, there is a choice between using Redshift serverless or provisioned cluster. And note that this is just the query engine. Your data can be sitting at a different place. All we are picking at part of this configuration is which query engine we want to use. I've already created a provisioned cluster specifically for this demo, so I'm going to use that one. Next section is about the type of authentication mechanism that Bedrock should be using when talking to Redshift. Now, Redshift offers 3 types of authentication mechanism. We support all 3 of them here. You can pick whatever suits your use case. I'm going to use secrets manager here. When I say by secrets manager, what it means is I've already created a database user with a specific permissions that I want my knowledge base to have, taken that username and password, put it into a secrets manager, and I'll just provide that secrets manager to Bedrock so that it can use it for accessing Redshift. So let's just do that. And final section of configuration is about where the data is actually stored. And as you can see, you can bring either the Redshift managed storage, which are the tables sitting inside your Redshift workgroup, or a provisioned cluster. But you can also use the Glue data catalog integration to bring any table, like any table, for example, from SageMaker Lakehouse, things like S3 tables, and use that query. I'm going to pick the simpler route for this demo and using the table, the database from the cluster that I had already created. So let's move on. Yeah. Now, next section, these are sort of advanced query configuration that we talked about before. This is useful if you're not satisfied with the out-of-box accuracy and you want to further fine-tune how do you, I'll say customization, if you want to customize the query generation process. There are things like description. So sometimes you will have ambiguous table names which are not obvious from the name what that table is storing or what that column is storing. So you can add a natural language description here. Second is inclusion-exclusion filter. It can help you reduce the search space for Bedrock when generating the query. It can specifically tell Bedrock that when you're using this knowledge base, only use this table or do not use these tables or columns. Lastly, there is curated queries. We'll come back to curated queries in the later part of the demo. So let's go to the next page. This page is all about reviewing all your configuration. If everything looks good, then we just go on and click the button. I think I moved to the slide faster. But I guess the idea was when you click review that page, click on the create button. Console will go and create the role behind the scene for you and also create the knowledge base. So as you already see, the knowledge base is created, but we are still not ready to query this. There is one more step that we need to do. And this step is syncing your knowledge base. To sync a knowledge base, we just select our query engine, we click on the sync button. Now, what is happening when we are syncing this? This is the step where Bedrock is actually fetching all the metadata schema, the table schema, and past queries from your database and building a knowledge bank behind the scene, which will be used at runtime to generate the SQL query. And note that in this process, we are not copying the actual data, but only the metadata related to your tables. So sync is complete, so we should be ready to test. Now, for context, I've been using the same mock database that Ron just showed you in his previous slides. So we're going to ask same questions around what was the top selling product in last month. So let's first test with the end-to-end drag flow that Bedrock Knowledge Base supports. This means that we'll not only retrieve from Bedrock Knowledge Base, but also generate a response. So to do that, we first need to select a foundational model. This is the model which will be used to summarize the response, which will be retrieved from Redshift. So let's ask the question, what was the top selling product in November 2024? Now, at this moment, what is happening is we are generating a SQL, we are going to execute the SQL, and then summarize the prompt using the LLM. And as we can see, car seats covers were the top selling product in our database. And as usual, like other experiences, we also have a citation where the query, the SQL query that was used for generating this response is returned as the cited response. Okay, so next question that I asked in this demo was to demonstrate the contextual nature of this conversational experience. Let me pause this one for a while. Yeah, so I guess the idea was that even if you ask a follow-up question, for example, what was the what is the current stock unit of the top-selling product? Bedrock understood what was the product ID in concern and generated the appropriate query and returned the right quantity. So I think we looked at an end-to-end flow of retrieval and generation, but sometimes you're not interested in doing end-to-end, and you're more hands-on and you want to build your own orchestration framework. So what you may need is just Bedrock to just do the retrieval for you. For that, you can always integrate with Bedrock's Retrieve API, and we'll do a demo of that. So in the console, if you want to do that, you can find all the three different layers of abstraction that we offer on a structured database. So let's move to just the retrieval part of the demo. I'll ask the same question, and this time, what we'll do is generate the SQL, execute the SQL, and just return the rows as it is. Okay, so as you see, this was the row that was returned, and this is exactly what was used by LLM to generate the natural language response in the previous step. Please forgive us on the UI for now. We are still working through some of the console improvements. You'll see a better looking experience hopefully in a few weeks. Next, we'll do the same thing, but this time we'll not even execute the queries, because sometimes you might be interested in directly just looking at the SQL query and do not want to execute that query. So we have launched a new API as part of this release called Generate Query API. This API can be used only against structured knowledge bases and returns you the SQL query corresponding to a natural language question. And this is actually the SQL query which was used in all the previous two demos that we just saw. Okay, so this walks us through one happy case scenario where things are working as expected. But what if you're not happy with what Bedrock knowledge base is generating? What if we want to take it further? So let's take some examples for those. Now, for this part of the demo, I intentionally added 3 ambiguous columns to my order table. I called those columns TS1, TS2, and TS3. Now, these are 3 different timestamps in the life cycle of an order history. And I'm going to ask Bedrock knowledge base, what was the time difference between order creation time and order shipping time? And because Bedrock does not know what these 3 timestamps in my database means, it's generating the wrong output. The correct answer for this actually should be TS2 minus TS1. So let's say if we have an example like this, how do we address that? What we need to do is we need to help knowledge base get more context on our table structure. And that's where we are going to take advantage of the description configuration of knowledge bases. So we edit the knowledge base. We go to description configuration. Here we can add the table name, column name, and a natural language description of what this column means. So as you can see, TS1 is going to be order creation time, TS2 is going to be order shipping time, and TS3 is going to be order delivery time. And this is not just limited to column. As you can see, column is an optional field here. So if you have a table where the table name itself is not obvious, you can also use this for giving a natural language description to your table. So once we add everything, we save, and we need to go back to the main page and sync again. So every time we make a change to our query configuration, we must resync our knowledge base. This is what is helping us refresh knowledge bank that has been created behind the scene with the new configuration. And here's the query, next attempt at the same query. And yes, as we can see, it generated the right query this time. So this is a good example where you have ambiguous column names or table names, and or you have maybe some custom logic specific to a column name, and you want to use it as a one-shot training to the generation process. Let's take another example. This one is going to be, again, from what Ron mentioned before. This is the where we have a concept called prestige partner. And in this company, the prestige partner is the top seller of a month. That is, like, every month's top seller is awarded the title of prestige partner. So right now, Bedrock does not know what prestige partner means. So let's see what it does when we ask this question. So as expected, because it does not have the context of what prestige partner means, the generated query just will actually output you the sellers that were onboarded in the month of October and not the top seller of the month of October. Now, this is the scenario where curated queries can be very helpful. So I think there are two good use cases of curated queries. One is something like this, where you have custom vocabulary, or maybe you have some complex SQL queries where you're not getting good accuracy out of the box. So for this example, we'll give the sample query, who was a prestige partner in October. I already have a query written with me, so I'll just paste it here. This query actually answers, returns the row with the top seller. We save it. We'll have to sync again. Now, just to show the fact that this is not just a lookup to your query, curated query, this time when I prompt the LLM, prompt the Bedrock, I'm going to ask the prestige partner in month of November. And what we will notice is that this time, when the query is generated, Bedrock will learn from the previous curated query example and replace the date with the month of November. OK, so as we discussed, yeah, so this has the month of November. OK, so this covers two advanced ways of customizing the query generation process for your use case. And on top of that, we recognize that safety is going to be very important. When you're building a chat interface on top of your data, you want to be careful that no unintended queries are getting executed in this database. So what we have done is we have added detection for any data modification queries, and those queries are automatically blocked by the system. So we'll look at some examples through demo. This time, what we'll ask this chatbot is just to delete a table. And Bedrock knowledge base is going to throw a user error saying that a non-read SQL was generated, and hence it cannot be executed. The same thing will also work if you try an update query. For example, if I just say that all the undelivered order, change the status to delivered. This will again be detected that this is a data mutating query, and it will be blocked by the system. So even though we have added these data protection into the system, but we highly recommend that whenever you use this, the permissions that you use to create this knowledge base should always be limited so that you are assured that no unintended queries are executed. And to recap how to do that is the IAM role or the database user that we created, which has the permission to access your database, that should ideally have only the limited set of permissions that you need for your use case. So yeah, this brings us to end of the demo section. Now I'll just recap before handing over to Ron what just we saw during the demo. We talked about what are the three configuration types when you're building knowledge bases. You can pick from different query engines. You can pick from different data storage types. By data storage, we mean it could be either a Redshift managed storage, or it could be a glue data catalog table, which can help you bring any SageMaker Lakehouse tables. And then we talked about different authentication mechanism, which was either you can use an IAM-based authentication or the Redshift DB user-based authentication. Next, we looked into some of the advanced query configuration that can help you customize your query SQL generation process. Lastly, we talked about some of the safety features that we have built in. So yeah, at this point, I'll just hand over to Ron to take it forward from here.
Thank you, Saket. So we're nearing the end of the presentation. Like at Amazon, at AWS, we take pride in working backwards from our customers. We're super excited to work with Oxys, who's building currently on top of Bedrock knowledge bases structured data. They've enhanced their conversational chatbot, their credit AI product, to also pull in data from their proprietary database. They're pulling in some of the database metadata from their own master data management solution. So we're super excited to kind of hear and see what they're going to be building with Bedrock knowledge bases. So just to recap, we talk about how really in the business, it's so key to have a customized AI experience. We looked at 4 ways to how to customize AI experience, which one of them is Retrieval Augmented Generation, or RAG. And it's all about providing foundational model access to the latest information from traditional data sources. It could be from document from S3. It could be from database engines. We believe unstructured data is best handled by semantic search, and there's going to be always relevance to that approach, where structured data can also be handled by natural language to SQL conversion, that what you saw before in the demo. And Bedrock Knowledge Bases is a fully managed service that orchestrates your RAG workflow, capable of handling both types of data. So the next step, I'm sure many of you are planning to fly home. So if you have some time over on the weekend, please try out Amazon Bedrock Knowledge Bases. If you haven't done it already, complete the survey. And if you have any specific questions, Saket and myself are going to be here. We'll stick around on the side. We still have some time. Come and say hi. We would love to hear about your use cases, and we would love to talk to you. With that, thank you very much for attending.